At BeFlexible, we are working to build a more adaptable, resilient and consumer-centred energy system for Europe. Our project includes 11 real-life pilots across Europe, where we explore how flexibility from buildings, industries and distributed energy resources can support the grid as renewable generation expands and electricity demand becomes increasingly dynamic. Across Italy, the BeFlexible project is testing how to unlock flexibility in the energy system, bringing together system operators, innovative technologies, and new actors to better manage the grid and support the energy transition.
The BeFlexible project aims to boost energy system flexibility, enhance the cooperation between distribution system operators, DSOs, and transmission system operators, TSOs, and ease the participation of all energy-related actors. In this context, the main objective of the Italian demo was to develop and implement relevant use cases to test in a simulated environment the cooperation between DSO and TSO about the qualification, selection, activation and validation of local and global flexibility services. Furthermore, in 2 pilots on field, one in Rome led by Areti, the other in Cuneo led by Enel, we tested different kinds of innovative devices as power grid user interfaces and phasor measurement unit to enhance the observability and controllability of low voltage and medium voltage grid, and to facilitate a broader customer participation in flexibility market. Finally, we developed a case study to evaluate the flexibility potential of energy-intensive plants in integrated water system infrastructure.
In the Rome pilot, local flexibility services are achieved through a coordinated digital ecosystem that is combining several devices and algorithms in order to address short-term constraints that can originate from the normal load and new technologies such as electric vehicles, heat pumps or gas-free housing that is greatly driving upwards the demand. At the core of the process is Areti Advanced Distribution Management System that forecasts load and production demand for up to 5 days for every node of the grid. This provides ample time to engage our flexibility providers to try to contrast congestion or peak load may happen on the grid. To enable this interaction, we are based on a PGUI device. This is a device that is installed in our customer houses that by communicating with the flexibility register is able to receive command and either increase the generated load put in the grid rather than decrease the load from a customer appliance. And a second device that is very useful for this use case is the PMU. This is done by improving grid observability. So by having better measures, we can better allocate our available flexibility and try to contrast whatever congestion or unexpected peak loads with pinpoint accuracy and avoid both waste of available flexibility and, on the contrast, congestion that may be caused by exceeding generated power.
In the Cuneo pilot, we validated a new communication architecture to support flexibility services. The architecture leverages on DSO infrastructure, on medium voltage standardized asset for medium voltage active resources, the controllore centrale d'impianto, and a new device is specifically developed inside the project for low voltage user that is called chain-free emulators. This allows us to prove how reliable can be the infrastructure of a DSO to provide flexibility services like observability and controllability. Observability is when we are able to send high granularity data from field to the center. Controllability is when we are able to control and send a specific command to several assets from the center to the field that allow us to manage possible criticalities on our grid. For example, a typical service is an active power modulation. To provide such kind of services, we also delivered a set of APIs that allow third parties, like a flexible service provider, to access to the cloud infrastructure of BeFlexible. Everything was tested here in Italy thanks to a flexible service provider, 1 medium voltage customer, and several low voltage users. Following this process, the day ahead, the DSO evaluate the necessary services to be activated in each area in specific time and send this schedule to the flexible service providers. The flexible service provider receives the schedule and divide it by each resources and send to them an activation schedule. At midnight, the BeFlexible devices start to interact with the field and follow the schedule defined by the DSO and the flexible service provider. At the end of the day, the DSO receives all the information from the field and compare it with the schedule and close the virtual set.
The need of coordination between TSO and DSO arises from the increased number of distributed resources providing service both for global market and local market. In our demo, we simulated two processes: the coordination in the validation process of resource providing service for both the system operator and the coordination in the daily market session that includes resources providing service both for local and global market. The first process, that is pre-qualification process of resources, is the coordination we simulated is named static traffic light, that considering complete information sharing among DSO and TSO, we imagine that the DSO can validate the information provided by resources connecting to their grids, even if the resource would provide service to TSO. Regarding the daily market session, we imagine to set a temporary limit process named the dynamic traffic light. The dynamic traffic light is a process running for each TSO market session and allow the DSO to set red or yellow or green light in specific grid portion. The red light means that the resource connected to the portion of the grid cannot modulate power to provide service for global market because of grid congestion. In case of yellow traffic light, the DSO can allow the resource, but the modulated power is partially limited. In case of green light, all the resources for all the validated power can provide service to the TSO without problem on the DSO grid. Other than this, we in our demo we simulated different daily market sessions. Imagine that there is a principle of mutual unavailability. It means that a resource providing service for a specific during a specific market session, starting from the DSO1, cannot provide the service for other system operator.
From a technological point of view, to make all this process happen, we successfully integrate the TSO and DSO platform to manage distributed resources. In particular, we integrate the TSO platform, named the Crowd Balancing Platform, and the DSO platform that for the BeFlexible project in the Italian demo was the Flexibility Register. Of course, this was not an easy work. We made a complex scheduling of the integration process during our demo, but this led to a good integration between the platform And this demonstrates that at least at the moment, with not so high number of distributed resources participating both to the local market and the global market, a coordination of shared resources is possible and it's feasible, and it also works well. But of course, this is a first try, so this needs to be optimized in the future. But it's a good starting point from the future implementation and the regulatory development.
Using water distribution networks as a source of electrical flexibility may seem unusual at first, but the water sector is one of the most energy-intensive industries in Italy. This is because it consumes approximately 2.3% of national electricity consumptions. This makes it a particularly relevant area in order to explore new flexibility solutions. In addition, water infrastructures are widespread across the country, and it makes these flexibility solutions replicable and scalable all over the country. Once the flexibility is demonstrated in a pilot without compromising service continuity, the same approach could be extended to other similar plants. In the pilot, we explored how the utilities can reduce its own electrical consumptions in order to reduce the load on the grid without compromise water supply or quality of the water. This was done mainly on pumping services, and we analyzed 4 representative water systems in Italy, operated by different utilities. These study cases reflect different network configurations, technology and water solution in order to complete knowledge of the flexibility into the systems. And for each site we collected data, we developed simplified hydraulic models, we simulate multiple operating scenarios to understand when and how the pumps could be reduced. The water systems possess its own grade of flexibility because storage tanks can temporarily buffer variations in pumping, while alternative water sources help maintain supply when pumping is temporarily interrupted. The pilot demonstrates that the water distribution networks can support electrical system flexibility while continuing to provide safe and reliable water services. And once this potential is unlocked, the pilot demonstrates that water distribution networks could support the flexibility market and help to share the flexibility all over Europe.
As the energy transition accelerates, projects like BeFlexible are key to unlocking a future where flexibility becomes a cornerstone of efficient, resilient, and sustainable energy systems. Stay tuned to discover more insights from our pilot implementation.